Hello friends, today I'm doing the question Ninja's training, which is the deep list from Stiver's list. So this is the question number first Ninja's training. So I put the link of this problem to the description. So yeah, the problem is uh, Ninja Boy, which is playing a game in this n days long training schedule. So each day he can perform any one of these three activities. So a boy ninja which has n day schedule and he has three activities to do every day. So he can do either running, either fighting, or practicing for learning new moves. So he can do one of these activities every day. So yeah, so each activity has some merit points on each day, as ninja has to improve all his skills so he can yeah. So the problem is ki, in a two consecutive day, ninja cannot uh, perform two same activities in consecutive days. So what we have to do, we have to ensure that if we are picking in a particular day, like in n minus one day, if he is running, then we have to ensure that in n minus twelfth day he has to fight or practice or learning a new moves. So yeah, this is a question. So let's understand from an example. Uh, so we have given 2D array, so in which we have n into 3 points. So yeah, so yeah, this is the array. So let's take this. So let's take this and yeah. So this is the array. So what we have given? We have given in one day we have given 1, 2, and 5. We have given 3 points. So either he can run or fight or learn new activities. So yeah, so we have three activities. So if ninja run on first day, this is the day one. This is day one. So in day one, if ninja fight, he run, then he got 1 point. If he fight, then he got 2 points. If he learn new moves, then he got 5 points. So what we have to do, we have to do for all the days, and we have to maximize the number of points. So in day two, let's see in day two. In day two, if he run, got 3 points. If he fight, got 1 point. If he learn new moves, then he will got 1 point. So run, fight, or learn new moves. So this is day two. Day two, and similarly in day three. In day three, uh, if run 3 points, if fight 3 points, and if learn new moves, then again 3 points. So this is day three. Run, fight, and learn new moves. So how we are going to do this? So let's see. So we have to maximize the number of points. So I'm assuming that in first day I'm taking this. So let's assume that ninja learning new moves in first day, so he will got 5 points on first day. So in day two, This is obvious that we cannot learn new moves because in consecutive days we don't have to perform the same activity. So either we can fight, or we can or a ninja can uh, run. Yeah, so either ninja can do this activity or this activity. So let's see, if doing this activity, then he can earn 1 points. But if he is doing this activity, is running, then he will get 3 points. So in day two he will run. He will run. So in next day again, we ninja cannot run because as given in the problem, in consecutive days we don't have to perform the same activity. So either ninja can fight or learn new moves. So in both two activities have same points. So we can fight, ninja can fight, or either ninja can learn new moves. So got 3 points. So total is 11 points he will got. So let's see what is the answer. So yeah, 5 plus 3 plus 3, which is 11. 11 will be the total number of points he got. So how we can do using dynamic programming? So let's see. Let's see how we're doing using dynamic programming. So we can do using tabulation as well as memoization method. So I am doing here using memoization. Let's not erase this. Yeah. So uh, yeah. So how we can going to approach this problem? Let's add new page, and yeah. Yeah, so here how we are going to approach this problem. So let's assume we have given some day. This is day 1, this is day 2, this is day 3. So we have given some activities points. We have given some activities points. So I'm saying that uh, we have given some points. Let's assume something. 5, 1, 2, 6, 7, 8, 9. Yeah. So this is running, fighting, and learning new moves. So we have 3 activities. So I'm this is day 3, this is day 2, this is day 1, this is day 1. So I'm iterating from last. So I'm doing it using memoization method. So this is a recursive approach, and we optimize this to dynamic programming. So uh, I'm saying that uh, if I choose this, if I if I learn new moves on the last day, this is obvious that on the previous of the last day, I don't have to perform this activity. So I can only perform either this or either this activity. So I can ask. So let's see, this is dp of n minus 1, and this is dp of n minus 2, m-2. So in the and this is the index. Let's say 0 for the running, 1 for the fighting, and 2 for learning. So I am saying, if I am learning, so and at animals one of the day, if I'm learning, then I'm saying the previous DP that, hey, can you say that on the running and learning, which is best for me? So this is no, this is fighting. Sorry. Yeah. So this is the learning on the last day is asking the previous DP that, hey, can you say me, can you say that running or fighting, which is better for me? So so this will ask, and we will add this to here. So this is the our 9. So this is 9 plus, we are asking this DP. So DP of n minus, DP of n minus 2, n minus 2, and which is indexing is 0 1, sorry, 0 1 and 2. So this is 0, and dp of n minus 2 1. So we have to take the maximum of these two, because we have to take the maximum of these two, max. Why max? Because uh, we see that if we are I'm doing the learning on the learning on the last day, then on the previous day, what I have to do? I have to run or fight. So this will return the maximum value. So again, this fight on day 2 ask this DP that, hey, can you say that if I fight on day 2, then on day 1, which is better for me, running or learning, which is better for me? So this will return which is better. So 4 is better. Four is better. If I fight on day 2, then I cannot fight on day 1. So I can ask day 1 that, hey, can you say that which is better, learning or running? So we can say that, yeah, learning is better for you. So this is return 4. So if this return 4, then I can say that, yeah. So on fighting DP, so on DP of n minus 2, and minus 2 fighting index is 1. So 1, we can store 4, this returns the 4. So 4 plus, so current is, if we're fighting the point is 2, the 2 plus, and this returns 4, repeat returns 4. So we're going to store 6 here. So similarly, we store all the values on DP, and at last we have to return uh, which is which is the max. So on the last day, if we run or fight or learn, so which is better? So if learn is better, then we have to return learn. If fight is better, then we have to return fight. If running is better, then we have to return the run, running maximum point. So yeah, this is my approach from the recursive approach, and I optimized using dynamic programming. So let's see the questions. Let's see the problem. So yeah, this is the problem statement, and this is my solution. So I did I used a DP of n into 3. So this is a constant 0 1 2. I'm storing here the uh, activities, and this is the index of the this is the days. So again, then here this function is given to me. So I'm storing -1 to all values of DP. So and I'm calling this function. I'm calling this function maxp, which store all the values in the DP, which stores all the values in DP. So at last, here. So let's see this function, how this is working. So I'm saying that we have to. I've given the pass the activity. So which activity I'm performing here, and what is the day? So index the day. So on which day we are performing which activity. So this is the point. So here, if index is less than 0, this is the edge case. So we have to return the 0 point, and if this is the DP, if this is -1, then we have to return. So if we pre-calculated the value, then we don't have to calculate again. So we can return here the uh, DP of index activity, and here we are doing it for the current index. We are performing all activity and see which is better. So Ninja is performing all activity. Ninja is running and seeing is running is better. So and Ninja is also fighting and see is fighting is better, or Ninja is also learning and see is learning is better for that day. So and at last I am returning the max value of that activity on that day. So yeah, this will work. And how this is working, as explained the explained here. So this is the point of that day, of that activity, and this is the previous days. So we not included the zero because for the consecutive days we don't have the same activity. So I am include the two activity, either one or two. So yeah, similarly for the one activity and learning activity. So yeah, that's it. uh, yeah, so that's it. This is my approach when programming. So time complexity is let's see what is time complexity. Okay. So time complexity is order of n. Yeah, order of n. Because this is the constant time, so this did take time much time. So yeah, order of n, and space is order of n, and order of stack space. So yeah, so time complexity is order of n, and space complexity is order of n, and plus order of stack space. So this is a recursion, so I'll take some space. So yeah, this is, thank you. That's it.